So let's read this question. Find the curve such that ordinate of any point of any of its points is the geometric mean between the abscissa and the sum of abscissa and subnormal at that point. Start off the problem by listing the key concepts involved. Key concept. And the key concept involved is length of subnormal, and we should know integration, as well as geometric mean. So a length of subnormal at any curve, at any point on the curve y equal to fx. Let's say this is one curve. So length of subnormal at point x1 y1 corresponds to the value of modulus of y1 times f dash of x1 at. So this is the length of our subnormal. All right. And the geometric mean says that if A, B, C are in GP, or B is geometric mean of A and C, we can say that B square equal to A times C. Here GP corresponds to geometric progression and GM corresponds to geometric mean. Alright, so we'll be using these key concepts to solve our problem. We were given that ordinate of any of its point is the geometric mean between abscissa and sum of abscissa and subnormal. So ordinate corresponds to the y coordinate and abscissa corresponds to the x coordinate. So we can say that it is given in the question that y square is equal to, which is square of its ordinate, is equal to abscissa times, which is x, times sum of abscissa and subnormal, which is x plus y times dy by dx. So this is what has been given to us. Now this is our differential equation and we need to evaluate the equation that corresponds to this differential equation. So on simplification, we'll say that y square is equal to x square plus xy times dy by dx, which means that y square minus x square upon xy is equal to dy by dx. It simply means that dy by dx is equal to y upon x minus x upon y. So what we have over here is a homogeneous differential equation. And to solve a homogeneous differential equation, what we do is we substitute the value of one variable with respect to another. So we are going to assume let v x equal to y. So this would mean that dv by dx times x plus v is equal to dy by dx. Alright, so hence we can say that if we replace this in our equation 1, and we'll call this as 2, so I'm gonna replace 2 in 1. This 2 corresponds to equation 2 and 1 corresponds to equation 1, and then I'll obtain v plus x dv by dx is equal to v minus 1 upon v. Hence I can say that x times dv by dx is equal to minus 1 upon v, because v and v will get cancelled on both sides because they are present on both sides. So hence now I can finally say that v dv is equal to minus dx upon x, and now I will integrate on both sides, and hence on integration we'll obtain integration of v dv is equal to integration of minus dx upon x. Integration of v dv corresponds to plus c, and integration of minus of dx upon x which corresponds to minus logarithm of x. So hence I can say that e to the power v square upon 2 plus c is equal to minus v square plus c is equal to x. This is my equation. Now in this equation we are gonna replace v with y upon x because y was equal to vx. So hence we can now say that e to the power minus of y upon x whole square times c is equal to x. This is our final equation whose differential equation would satisfy our given condition. So I hope you understood it well, and